Hi boys and girls, this is lecture 8.4. Today's review topic, Motion, Part 1. Today we're going to discuss three closely related concepts: position, velocity, and acceleration. Position is x of t, and it determines where the object, often a particle, is located, possibly on the x-axis, at a given time t. Velocity, v of t, is equal to the first derivative of position. It determines how fast the position is changing at a time t, as well as the direction of movement. If the velocity is positive, then that means the particle or object is moving to the right. If the velocity is negative, that means the particle or object is moving to the left. Acceleration, a of t, the first derivative of velocity, the second derivative of position, determines how fast the velocity is changing at time t. The sign indicates whether the velocity is increasing or decreasing. A positive acceleration means the velocity is increasing. A negative acceleration means the velocity is decreasing. Let's review some basic vocabulary and assumptions, just to be sure we always understand what the question is referring to. If x of t represents the position of a particle along the x-axis at any time t, then the following statements are true. Initially means when time equals 0. At the origin means position is equal to 0. At rest means velocity is 0. If the velocity of the particle is positive, then the particle is moving to the right. If the velocity of the particle is negative, the particle is moving to the left. To find average velocity over a time interval, divide the change in position over the change in time. This is your generic slope formula, change in position over change in time, and that gives you average velocity. Instantaneous velocity is the velocity at a single moment or instant in time. We have to use a derivative to find instantaneous velocity. If the acceleration of the particle is positive, then the velocity is increasing. If the acceleration of the particle is negative, then the velocity is decreasing. In order for a particle to change directions, the velocity must change signs. From positive to negative or negative to positive velocity means the object has changed direction. One way to determine total distance traveled over a time interval is to find the sum of the absolute values of the differences in position between all resting points. Here's an example. If the position of the particle is given by x of t equals 1/3 t cubed minus t squared minus 3t plus 4, find the total distance traveled on the interval 0 less than or equal to t less than or equal to 6. So from t equals 0 to t equals 6, what was the total distance traveled by this particle? It may seem as though we could find position at t equals 0, x of 0, and position at t equals 6, x of 6, and subtract the two. That would give us net distance traveled, but would neglect to take into account the possibility that the particle had changed direction. For us to know whether or not the particle changed direction during that time interval, we'll need to look at where velocity was 0. So let's find the velocity function. V of t is equal to t squared minus 2t minus 3. Setting the velocity equal to 0 and factoring gives me t minus 3, t plus 1. This means there were two times when velocity was 0, at t equals 3 and at t equals negative 1. T equals negative 1 is not in the time interval we're considering. So we're going to need to know where the particle was at t equals 0, where the particle was at t equals 3, and where the particle was at t equals 6 to determine total distance traveled. X of 0 is 4. So at time 0, the particle was at position 4. X of 3 will be 1/3, 3 cubed, minus 3 squared, minus 3 times 3 plus 4, and that will be negative 5. So x of 3 is negative 5. At time t equals 3, the particle was at position negative 5. Now let's find x of 6. That's going to be 1/3. 6 cubed minus 6 squared minus 3 times 6 plus 4. And that is 22. So at time t equals 6, the particle was at position 22. This means it started here at time t equals 0, position 4. It went to the left initially, and 9 units to the left took it to position 5, and this was at time t equals 3. Then it moved to the right until it reached position 22, and this was at time t equals 6. To get from negative 5 to 22, it traveled 27 units. So from 4 to negative 5 was a distance of 9 units. From negative 5 to 22 was a distance of 27 units. This means that the total distance traveled by this particle from time t equals 0 to t equals 6 was 36 units. The data in the table below gives selected values for the velocity in meters per minute of a particle moving along the x-axis. The velocity v is a differentiable function of time t. So let's see if we can answer these questions. At t equals 0, is the particle moving to the right or to the left? Explain your answer. Since velocity is negative 3 at t equals 0, we know the particle is moving to the left. Why? Velocity is negative there. Is there a time during the time interval 0 less than or equal to t less than or equal to 12 minutes when the particle is at rest? Explain your answer. We know the particle is at rest when velocity is 0, and there are no 0 values given here. However, v is a differentiable function, which means it's continuous, and since the velocity changes from negative 3 to 2, we know that it must have gone through 0 at some point during this interval. So we can say yes. We know this because velocity changes signs. Use the data from the table to find an approximation for v prime of 10 and explain the meaning of v prime of 10 in terms of the motion of the particle. Show the computations that lead to your answer and indicate units of measure. Well, v prime is acceleration, so v prime of 10 would be acceleration of the particle at t equals 10. How can we find acceleration? We don't actually have a velocity at time t equals 10, but we can use the closest data available, what's happening at t equals 8 and what happens at t equals 12. We can find the average change in velocity, which will be acceleration at t equals 10, by using a slope formula with these two data points, the change in velocity over the change in time. So we'll say 5 minus 7 over 12 minus 8, which is negative 2 over 4, or negative 1/2. So we'll say v prime of 10, which is acceleration at 10, is negative 1/2 meters per minute squared. Make sure you include the units of measure. Let a of t denote the acceleration of the particle at time t. Is there guaranteed to be a time t equals c in the interval 0 less than or equal to t less than or equal to 12, such that a of c equals 0, and justify your answer? Well, we don't have acceleration information given, but we can observe the behavior of the velocity in order to determine what's happening with acceleration. Notice that at time t equals 6, the velocity is 5. At time t equals 12, velocity is 5. Since velocity is differentiable, it's continuous, and for it to have gone through 5 and back to 5, there had to be a point at which the slope of velocity was 0, which means acceleration was 0, and this is guaranteed by Rolle's theorem. So by Rolle's theorem, we can say that yes, there is a place where a of c will equal 0 in that interval. The graph below represents the velocity v in feet per second of a particle moving along the x-axis over the time interval from t equals 0 to t equals 9 seconds. So let's see if we can answer these questions. At t equals 4 seconds, is the particle moving to the right or to the left? As you can see, at time t equals 4, velocity is positive. That means the particle is moving to the right. Why? Velocity is positive. Over what time interval is the particle moving to the left? And explain your answer. The particle will be moving to the left when the velocity is negative, and that's happening from time t equals 5 to time t equals 9. So t equals 5 to t equals 9 is when the particle is moving to the left. That's where velocity is negative. At t equals 4 seconds, is the acceleration of the particle positive or negative? Explain your answer. Acceleration is the derivative of velocity, so we'll look at the slope of this velocity function to determine whether acceleration is positive or negative here. At 4, the slope is negative. That means acceleration is negative there. Why? Slope of the velocity function is negative. What is the average acceleration of the particle over the interval 2 less than or equal to t less than or equal to 4? Show the computations that lead to your answer and indicate units of measure. We can find average acceleration by looking at change in velocity over change in time. So let's calculate v of 4 minus v of 2 over 4 minus 2. v of 4 is 6. v of 2 is 9. 6 minus 9 over 2 gives negative 3/2. The units here are feet per second squared. Is there guaranteed to be a time t in the interval 2 less than or equal to t less than or equal to 4 such that v prime of t is equal to negative 3/2 feet per second squared? Justify your answer. This is asking whether or not the mean value theorem applies here. We found an average acceleration of negative 3/2 feet per second squared. Is there a point at which the exact acceleration is negative 3/2 feet per second squared on that interval? In this case, it's not guaranteed because there's a point in the interval which is not differentiable. So we're going to say no, velocity is not differentiable on that interval. At what time t in the given interval is the particle farthest to the right? Explain your answer. The particle is moving to the right when the velocity is positive, and it's moving to the left when the velocity is negative. So at this point in time, it had reached its farthest point to the right at time t equals 5. Why? Because velocity changes from positive to negative. A particle moves along the x-axis so that at time t its position is given by x of t equals t cubed minus 6t squared plus 9t plus 11. At t equals 0, is the particle moving to the right or to the left? Explain your answer. We'll need the velocity function to answer this question. v of t is equal to 3t squared minus 12t plus 9. What is v of 0? 9. This means our answer will be right. The particle is moving to the right. Why? Velocity is positive. At t equals 1, is the velocity of the particle increasing or decreasing? Explain your answer. We'll need acceleration to answer this question. Acceleration is 6t minus 12. What is acceleration at 1? That's going to be negative 6. So our answer will be decreasing. Why? Because acceleration is negative. Find all values of t for which the particle is moving to the left. Let's set the velocity function equal to 0 to see if there were times when the particle was at rest. 0 equals 3t squared minus 12t plus 9. Let's divide both sides of this equation by 3. T squared minus 4t plus 3. And now factor. 0 equals t minus 3, t minus 1. So there were 2 points at which the particle was at rest, at t equals 3 and at t equals 1. Let's find out what was happening in these intervals. When t was less than 1, when t was between 1 and 3, and when t was greater than 3. Let's determine the sign of the velocity in each of those intervals by using test values. We'll use 0, 2, and 4. V of 0 is 9, a positive number, so the particle was moving to the right. V of 2 is negative 3, so the particle was moving to the left. V of 4 is 9, so the particle was moving to the right. Therefore, the answer to this question, when t was between 1 and 3, the particle was moving left. Find the total distance traveled by the particle over the time interval 0 less than or equal to t less than or equal to 5. Let's make a chart. We're going to want to know position at the endpoints of the interval, but also when the particle was at rest. So we're going to look at time 0, time 5, but also when the velocity was 0, at time 1, and at time 3. Position at time 0 was 11. At time 1, 15. So 4 units to the right. At 3, back at 11. This was 4 units left. And then at 5, we're at 31, which is 20 units to the right. So we know that the total distance traveled by this particle, 4 plus 4 plus 20, is 28 units. For our last example, we have a free response question from the 2000 AP exam. 2 runners, A and B, run on a straight racetrack for 0 less than or equal to t less than or equal to 10 seconds. The graph above, which consists of 2 line segments, shows the velocity in meters per second of runner A. The velocity in meters per second of runner B is given by the function v, defined by v of t equals 24t over 2t plus 3. Letter A asks, find the velocity of runner A and the velocity of runner B at time t equals 2 seconds. Indicate units of measure. Well, this graph represents the velocity of runner A. He started at velocity 0, and his velocity was increasing at a constant rate until t equals 3. At that point, his velocity was 10 meters per second. For the rest of the time interval, he ran at a constant rate of 10 meters per second. We can't quite tell what the velocity was at t equals 2, but we can use the slope of this line to determine the rate at which the velocity was changing, and that will be used to find the velocity at time t equals 2. So for letter A, for runner A, we're first going to find the rate at which the velocity was changing on the interval from 0 to 3. So that will be change in velocity, 10 minus 0, over change in time, 3 minus 0. So on that interval, his velocity was changing at a rate of 10/3 meters per second squared. Let's multiply that by 2 seconds to find out what his velocity was at time t equals 2, and that was 20 over 3 meters per second. For runner B, we can use the velocity function given. We'll need to find v of 2. That will be 24 times 2 over 2 times 2 plus 3. This is 48 over 7 meters per second. Letter B. Find the acceleration of runner A and the acceleration of runner B at time t equals 2 seconds. Indicate units of measure. Time t equals 2 falls within this interval from 0 to 3, and the slope of this line represents the constant acceleration of the runner at this time. This can be calculated by change in velocity over change in time, and in fact we calculated this in letter A in order to find the velocity at time t equals 2. So change in velocity over change in time during that interval is 10/3 meters per second squared, and that is the acceleration of runner A during that time interval. The acceleration of runner B will be found by finding v prime of 2. Since this is on the calculator allowed section of the exam, you can use the n-derived function of your calculator to find this derivative. At time t equals 2, runner B was accelerating at 1.469 meters per second squared. Letter C. Find the total distance run by runner A and the total distance run by runner B over the time interval 0, less than or equal to t, less than or equal to 10 seconds. Indicate units of measure. Well, since this is the graph of the velocity of runner A, finding the area under this curve will give us his total distance traveled. So let's start with this triangle. The base is 3, the height is 10, so this will be 3 times 10 over 2, which is a total area of 15. Then for the rectangle, the length is 7 and the height is 10, so 70 is the area of the rectangle. Therefore, runner A traveled a total distance of 85 meters. For runner B, we can find the total distance traveled by integrating his velocity function from 0 to 10. That means we'll find the integral of 24t over 2t plus 3 dt from 0 to 10. Since this is on the calculator allowed section of the exam, use the integrate function in your calculator to evaluate this integral. The total distance run by runner B was 83.336 meters. Here are the scoring guidelines for this question. In letter A, 1 point was given for the correct velocity for runner A, another for the correct velocity for runner B. In letter B, 1 point was given for correct acceleration for runner A, and another for correct acceleration for runner B. In letter C, 2 points were given for distance for runner A, 1 for the method, so make sure you show the calculations you used in finding the areas under the curve, and another for the correct answer. And 2 points were given for the distance for runner B, 1 for the correct setup of the integral, so even though you're using your calculator to evaluate the integral, show the setup of the integral, and 1 for the correct answer. The 9th point was given for units, meters per second in part A, meters per second squared in part B, and meters in part C. Tip number 4 for the AP Calculus AB exam. If you use your calculator to solve an equation, write the equation first. An answer without an equation might not get full credit, even if it is correct. Similarly, if you use your calculator to evaluate a definite integral, write the integral first. An answer without an integral will not get full credit, even if it is correct. We saw this in the previous free response question. Common student error number 4. If the correct answer came from your calculator, the grader will assume your setup was correct. Au contraire, my friends, make sure you show the setup of your work before using your calculator to get the answer. That's it for today's lecture. Let's see if you can finish this sentence. Calculus is number. God bless you, boys and girls.